All right, let's talk about a real giant in the software world, the Spring Framework. Today, we're going to demystify it and really dig into the core ideas that made it so incredibly dominant.
So if you've spent any time at all in the world of enterprise Java, you've definitely run into Spring. But what is it, really? What does it actually do? And how in the world did it get so ridiculously popular?
And, with a name like Spring, you gotta ask, does it have anything to do with the actual island of Java?
Nope, absolutely nothing. But honestly, that volcano metaphor, it's not a bad one. Because back in the day, building big enterprise apps felt a lot like trying to climb a volcano. It was this huge, dangerous, and incredibly difficult task. Okay, so let's rewind a bit. To really get why Spring was such a game changer, we have to look at the world it was born into and the huge problems it was designed to solve.
Back in the early days, you had this thing called J2EE. And let me tell you, it was complex. We're talking about these massive, heavyweight applications that needed a giant application server just to run. And developers? Oh man, they were just drowning in repetitive boilerplate code for even the simplest tasks. But the worst part was that the important stuff, the actual business logic, was all tangled up with the infrastructure plumbing. It made things a nightmare to change, and even worse to test.
And this is where Spring comes in with a totally radical idea, a complete shift in thinking called inversion of control, or IOC. And this one idea, it's the heart and soul of the entire framework.
So what does that even mean, inversion of control? Well, normally your code calls the shots. It controls the framework. With IOC, you flip that completely on its head. The framework controls your code. You just write your business components and then you just hand them over to Spring. You're basically saying, hey, Spring, you're in charge of creating these objects, wiring them together, and managing their whole life. It's a total 180 from the old way of doing things.
And the whole process becomes just so much simpler. You write your plain old Java objects, your POJOs, with your business logic. You just tell the Spring container about them. And that's pretty much it. From there, Spring takes the wheel. It creates your objects, wires up all their dependencies, and manages everything for you. All you have to do is just ask for an object when you need it.
Okay, so if inversion of control is the big idea, the what, then dependency injection, or DI, is the how. This is the actual magic that makes it all work.
I love this analogy. Think of yourself as a chef in a huge professional kitchen. You don't have to worry about growing the vegetables or anything like that, right? You just say, I need a carrot or I need a chicken breast. And the kitchen staff, that's the framework, brings it to you all ready to go. That's exactly what your code does. It just declares what it needs, its dependencies, and the Spring container injects them for you.
Now, in the beginning, how did you tell Spring about all this? Well, you used these massive XML files. You had to define every single little component, what Spring calls a bean, and then manually lists out every single thing it depended on. I mean, it worked, but wow, was it a lot of typing. So verbose. But fast forward to modern Spring, and it's a completely different story. It is so much cleaner. You just use one simple little annotation at auto annotation. You put that on your dependency, and bam, Spring figures out what to do and injects it for you. All of that XML we just saw, gone, replaced by one single word. It's kind of amazing.
Now, Spring gives you a couple of ways to do this, but what the team recommends really tells you a lot about their philosophy. They push for something called constructor injection for things your object absolutely must have to work. Why? Because it guarantees your object is born in a complete valid state. Plus, it makes your code way easier to test. There's also setter injection, which is still useful, but it's more for optional things, stuff you might want to add on later.
And yeah, the official docs really nail it. It's all about pushing you towards building components that are solid, robust, and preferably unchangeable or immutable. And honestly, that's just good software design, period.
Okay, so dependency injection is a huge piece of the puzzle, but Spring has another really powerful trick up its sleeve. It's called aspect-oriented programming, or AOP for short.
So what on earth is that? Well, think about all the stuff that needs to happen all over your application, but isn't part of your core business logic. Things like logging, security checks, or managing database transactions. These are called cross-cutting concerns because they cut across everything. AOP is a super clever way to pull all that logic out. Put it in one place, called an aspect, and then just weave it into your application without ever having to change your actual business code. It's pretty slick.
And the way it works is kind of magical. Spring secretly creates a proxy object that sits in front of your real object. So when something tries to call your code, it's not actually talking to your code directly. It's talking to the proxy. And that proxy can do stuff first, like, hey, let's start a transaction. Then it calls your real method, and then it can do stuff after, like, okay, transaction complete. It's like having a little secret agent for your code.
The stage crew analogy here is just perfect. Think about it. Security, transactions, caching, they're all like the crew backstage in a play. They are absolutely critical for the show, but you don't see them on stage. They let the main actors, your business logic, do their thing without getting in the way.
So, Spring isn't just one thing anymore. Over the years, it's absolutely exploded into this whole universe of different projects. But what's really cool is that they're all built on those same core ideas we just talked about: IOC, DI, and AOP.
You've got Spring Boot, Spring Data, Spring Security, Spring Cloud. The list just goes on. Each one tackles a specific problem, whether it's talking to a database or building microservices. But they all share that same DNA, that same philosophy of making the developer's life easier by having smart defaults instead of tons of configuration.
And we have to talk about Spring Boot for a second, because it was a massive game changer. Remember those giant clunky application servers from the beginning? Spring Boot got rid of them. It just embeds a tiny web server right inside your application. That one simple idea completely changed how we deploy Java apps, and honestly, it's what made modern microservices and cloud development really possible in the Java world.
So that brings us to the big question. How has Spring stayed so successful, so relevant, for more than 2 decades now? It's pretty amazing when you think about it. And the answer really comes down to its core philosophy.
It's all about the developer. Spring doesn't force you down one path. It gives you choices. It's flexible. It cares deeply about not breaking your old code with new releases. That's huge. This obsession with quality, with good API design, and with long-term stability, that's why people trust it. That's why they build their most important stuff on it.
So, we started with a question. By giving up control to a framework, do you actually get more power? And I think the story of Spring gives us a pretty clear answer. By letting the framework handle all the messy, complicated, repetitive stuff, you, the developer, are free to focus on what actually matters: solving the real business problems and building great applications. You let go of that low-level control, and in return, you get this incredible boost in power and productivity.